Hello children, welcome to channel Sube. Children, today I am going to discuss question number 6 from the MCQ part of 2021 Physics new syllabus paper. A block of mass capital M moving at velocity 2v on a flat frictionless surface makes a perfect inelastic collision with another block of mass capital M moving at velocity v along the same direction. What is the velocity of the first block after the collision? So they have given answer 0, half v, 3 divided by 2v, then 2 times v. So let us draw a little sketch to illustrate this the story. So there is a block whose mass is m, and the other one also as same, the mass m, both are. So let us write mass is m of this one also. The velocity of this one is 2 times v here, then the velocity of the other block is v to the same direction. So this one is slow, therefore there is a possibility to collide this first one to the second one with the second one. So after the collision, these blocks must move together. That means they must stick to each other. They must stick to each other because in the question they say perfect inelastic collision. If the collision is a perfect inelastic collision, they don't bounce. They don't bounce. So therefore, they must stick together and move together as a one object. So that is the key of this question. If you don't know that, what are these perfect inelastic collisions? If you don't know that they stick together, remember that example, the mud ball. If we throw a mud ball to a wall, it sticks. So that types of collisions are called perfect inelastic collisions. So that is the lesson. If you remember the lessons, no problem. You can decide that these two objects stick together. It is not mentioned in the question. So that is the physics part of this problem. So that should come from your mind. That should come from your mind. They have not mentioned that. That is what they are going to check, whether you know that or not. So the velocity is what they want us to find. Therefore, let us write it as x. So we can apply the rule of conservation of linear momentum for both types of collisions. Whatever the collision, doesn't matter. Without thinking too much, we can apply to whatever the collision this rule. So therefore, let us now apply conservation of linear momentum rule. What we are going to do, the momentum, we are going to write momentum terms. What is momentum? M times v. So let us write that for this first one, first object, capital M times 2v, the velocity of that is 2v. So plus not minus, because velocity of this second one is directed to the same direction. So therefore mv term is just m, velocity is v. So that is the total momentum before the collision. Then it must be equal to the total momentum of the objects after collision. So this one is now moving as a single object. It's a compound. So 2 times m is the mass. So x is the velocity that we don't know. So just we have to now find it out. So now we can simplify. We can cancel m from each terms. Then we get 2v plus v equals 2 times x. So 2v plus v is 3 times v equals 2x. So x equals 3v divided by 2. So the answer is 3v divided by 2. 3v divided by 2. This one is the answer. The fourth one is the answer for this question. So let us check the answer sheet 2021. What is the question? Question is number 6. Number 6. The answer is fourth one. Right. So the number is answer is fourth one. So this one is correct. So children, today I have not much to do. Therefore, I am going to show you some target questions. So I can design small types of target questions, because now already this question has been answered. This one is a past paper, so you will not be given this question again. Next time you will write the exam. When you write the exam, you will get a new question. So therefore they change a little bit from past papers, and sometimes they give new questions. So however, it is better if we do some target questions. So let us do it now. So children, let us try to do this target question. A block of mass capital M moving at velocity 2v on a flat frictionless surface makes a perfect inelastic collision with another block of mass capital M moving at velocity v along the same direction. So that part is as same as previous problem. The same thing I copied down. Then what they ask is, what is the kinetic energy lost after the collision, not the velocity. So let us try to solve this. So there are answers here like this. So first what we have to do, we have to find out the velocity as previously, as the same way as previously we did. So therefore I just copy down this part. That means we have to apply conservation of momentum rule and find out the velocity the same way as we did previously. So this part you can't avoid. You have to do this part first, and then now you know the velocity. Now you know the velocity. So let us write, therefore, now we know the velocity, 3 times v divided by 2. As you did, as you solved the first question, the same way you have to apply conservation of linear momentum to this object and this object, and total amount you get, and after that you equate it with this final momentum, multiplying the total mass and the velocity symbol x. So you gotten this velocity, and now after that you have to go further. What they ask is kinetic energy lost. Kinetic energy lost. So that means the total kinetic energy before the collision. Total kinetic energy before the collision, and the total kinetic energy after the collision is not equal. Total kinetic energy after the collision must be smaller than the previous one, initial one. So the difference of the kinetic energy is the lost. So therefore we have to calculate delta E, kinetic energy difference. So that means before minus after. kinetic energies, you have to subtract after the kinetic energy after the collision. You have to subtract from before value, previous value. So therefore we have to calculate this one first and this one then, and we have to subtract after that. So let us do it now. So this one is the path. So let us find first kinetic energy of this part, previous one, half mv squared is what we have to find out. There are two objects, so half mv squared, again half mv squared. So half, this one is m, this one is 2v, then half m, capital M, 2v, you have to square it. 2 times 2 is 4, 4v squared. Then again half the kinetic energy of this one, just mv squared, capital M v squared. So let us simplify like this. 2 times to 4, then what we get, m, 2 times m v squared plus half m v squared. So total 2 half mv squared. That means 2 times 2 is 4 plus 1 is 5, then 5 divided by 2 mv squared. So here we don't write equals and this part, because in this conservation of linear momentum rule, when we apply that, we did write that equal sign, but here we don't write that because we know these are not equal. That's why they ask to find out the kinetic energy lost. So if there is a loss, this one is smaller, that means less than this one. Therefore we can't write equal sign. Just we simplify the left side, we find the total kinetic energy. So this one is the total kinetic energy before, total kinetic energy before the collision or initial kinetic energy. So what we do is we calculate that like this separately, we divide it. There's no we are not going to equate it. So now let us find final kinetic energy, because we have to subtract it from the initial one. So final kinetic energy, just what we have to do is we have to write half mv squared term. So half, what is m final? This one, m is 2m. So 2 times capital M. Now v squared. V squared is 3 times 3 is 9. V times v is v squared. 2 times 2 is 4. So this value is the squared value of velocity. So here that one. Now this 2 cancel, then 9 divided by 4 m v squared. So let us do a little adjustment to this term, because there is a 4 at the denominator. So let us multiply this number by 2. So we get 10 divided by 4. Then it will be easy for us to simplify. So now let us so now what we have to do, we have to subtract. Let us apply to this equation now. We have to get the difference, initial kinetic energy, final kinetic energy. So subtract like this, then 4 common, 10 minus 9 is 1, we don't have to write, doesn't matter, mv squared. So this is the answer. This is the answer. They have asked us to find out the kinetic energy lost after the collision. The kinetic energy loss. So this one is the answer. The second one, quarter mv squared. That is the answer. Here you see, and that is the kinetic energy lost after the difference after the collision. So children, I think you understand. So they might give a question like this in next time when you use it for the exam, because this one is a past paper. So I changed a little bit like this, so they might do the same thing. So now you are ready. So like that, let us do another target question today. So now the question is same, children, but I have changed this word. Previously it was along the same direction, but I have changed it as opposite direction. Now the second object is coming from the opposite direction. That is the only thing I changed here. What is the velocity of the first block after the collision? Again they are asking the velocity. So let us draw a little sketch. So this one is the first one. The second one, the mass same. So after collision, what happens? Still perfect inelastic collision. Therefore they must move together, stick to each other, stuck to each other. So like this. If it is a perfect inelastic collision, they must move together. So this is the diagram. So you have to keep in your mind that thing. What if it is given as a perfect inelastic collision, the objects after the collision move together because no bounds. So the velocity of this one, 2 times v, the mass capital M, here also the mass capital M. I didn't change those things. So the direction is not like the same direction. Even the previous one was like that, but here now I have changed it to opposite direction. So the velocity is v along the opposite direction. The velocity v along the opposite direction. So like this. So after the collision we don't know the direction. Just let us take as positive to the positive direction, because we taken this direction as positive as previously. So now let us apply that conservation law. What? Linear momentum conservation. Now what we have to do? mv part, m times 2v, then here minus, because the velocity is opposite. Velocity is opposite. So minus mv equals the total 2m here, total mass 2m, because they are stuck together now. So 2 times m, the velocity is x. So let us simplify. M cancel, 2v minus v equals 2x. So now 2v minus v is v equals 2x, then x equals v divided by 2. So let us choose half v, or v divided by 2 is same, so half v is here. So this one is the answer, the second one. So children, I decided to give you this target question and solve it, because to show you that how to solve if the direction of this velocity is opposite. So you have to take the negative value to show that. That is why I solve this problem as an example, so that you can see it and learn it. So children, now I am going to show you how to solve this target question number 3. A block of mass capital M moving at velocity 2v on a flat frictionless surface makes a perfect inelastic collision with another block of mass capital M moving at velocity v along the opposite direction. What is the kinetic energy lost after the collision? So first of all, we have to find out the velocity. So here is the diagram. The mass of first one is capital M, the velocity is 2v. The mass of the second object is also capital M, but opposite side, the opposite direction, the velocity is v. Velocity v, opposite direction. So like this. So the objects stick after collision because perfect inelastic collision. So the common velocity we take as x. So the direction, this side we take as positive. Then let us write the equation conservation of linear momentum. mv parts we have to write. So capital M, v is 2 times v. We write for this one first, and then we write for this one. What is the sign? Because this velocity is opposite, we have to write minus, because momentum is vector. Momentum is a vector. Therefore minus capital M v. Momentum must equal whatever the collision, 2 times m mass, total mass, the velocity we have taken as x. So simplify, then 2v minus v equals 2x, then v equals 2x, then x equals v divided by 2. So now we know x equals v divided by 2. Now we have found the velocity. Now what we have to do? We have to find out the total initial kinetic energy separately and total final kinetic energy, because there is a velocity, there is a mass. So total kinetic energy is before and after initial value and final values, and subtract them to find out the energy lost. So let us take the topics from previous one like this, then let us write it, keep it here like this, then it is very clear if we use topics like this, final one here. So let us write now the equation for initial kinetic energy. So kinetic energy of this one is what? Half capital M v, this one is squared, 2 to 4 v squared, the 4 times v squared, then plus kinetic energy of this one. Even though the direction of the velocity is to left, we don't write minus. That is important. That is what I want to show you. That is why I took this problem to show you, because kinetic energy is not a vector. Kinetic energy is a scalar. Therefore no sign, positive, whatever the direction, positive, because this one is kinetic energy, this one is kinetic energy, direction doesn't matter. So here we write positive, but here we used negative, because that is a vector, momentum is a vector, but here kinetic energy is a scalar. So positive half mv capital M, velocity is v squared. So let us simplify, I don't take much time. 2 half mv squared then 2 times 2 4 plus 1 5, 5 divided by 2 mv squared, then 10 divided by 4 mv squared. This one is the initial kinetic energy. So the final kinetic energy, this one 2m, then half 2m, velocity v squared 2 to 4, v squared divided by 4, then 2 cancel, mv squared by 4, mv squared by 4. So we have to now take the difference. So let us use this equation, because we have to find the energy lost. So initial value, this one, this one, final value, this one, keep it here, then subtract, then 4 common, 10 minus 1 is 9 mv squared. A big amount. Previously same problem, this one, same direction, not opposite, still perfect inelastic. It was quarter mv squared. Quarter means 0.25 mv squared. 0.25, not even 1.25. The lost. Here, how much the lost? Divide this. 2 times 2 9, then 8, 1, then 10, then again 2 times, then 5 mv squared. A big amount has been lost. A big amount, 2.25 mv squared. Previous, because opposite direction, the other object is coming from opposite direction, but same velocity, same mass. Previously, when they move to the same direction, 0.25 mv squared was the lost, energy lost. So this one is a very big amount. That is why when two vehicles crash together, if the other one coming from the opposite direction, they both get a big damage. Because the damage is the energy to create that damage is given by this energy lost. So this energy is used to make that damage, to bend the metal plates of the vehicle and to break everything. So this energy is used. So this second time, that means coming from the opposite side, since the energy lost is very big, the damage is very big. So that is why you have to know after solving these types of questions. So children, so the answer is what? 9 divided by 4 mv squared. So this one is the answer for this question. So children, I think this calculation may be very useful you to understand something, how this damage occurs if coming from the opposite side, the other vehicle. So we can understand that since this energy lost, kinetic energy lost is very big, so the damage is also very big. Children, I think you are happy today because I solved a lot of questions, lot of problems, examples, target questions, and the original one also. So I will be happy if you subscribe my channel. I must say thanks for those who have already subscribed my channel, and for those who watch my videos. Do it again and again, then it will be beneficial for you and me both. Then see you tomorrow. Goodbye.